Hello, students, and welcome to our lesson today. We will talk about how to add and subtract fractions with unlike denominators. And let's be reminded that we have a quiz on Friday. Today is Wednesday, October 13th, and it is a B day. So you've probably already participated in Calm Classroom. We will now have our lesson on adding and subtracting fractions with like denominators. Please keep your binder updated and return all materials at the end of class. You will have been successful when you have actively participated in our opening meditation, when you have completed your work page and you understand how to use least common multiple to generate like denominators, and when your binder is updated with all your work. So by now you should have your binder and your paper, your pencil sharpened, and be ready to go. So let's move forward with our first problem. We started working on these yesterday, and I must say everybody did pretty well with it. We're jogging our math memory from last year. So in the first example, we are asked to subtract 7/12 from 5/6, but we need to have the same like denominators in order to complete this problem. So what I need is the LCM of 6 and 12. So I do know that 6 is a factor of 12. So if 6 is a factor of 12, that means that 12 would be the least common denominator, least common multiple, excuse me, not denominator, least common multiple of 6 and 12. So that means I need to find an equivalent fraction for 5/6 that has a denominator of 12. Well, in order to get from 6 to 12, I multiplied the denominator by 2, which means I'll multiply the numerator by the same thing. So 5 times 2 is 10. So that means that 10/12 and 5/6 are equivalent fractions. Now I can subtract. So I'll rewrite my problem as 10/12 minus 5/6. I'm sorry, minus 7/12. Sorry about that. Haven't made a recording since last year, so getting back into it. Let's make my line a little thicker too. So 10/12 minus 7/12. So our answer will be in twelfths, and I just simply have to subtract the numerators. 10 take away 7 is 3. So my answer is 3/12, but now I need to look at that answer and I need to say, can I simplify that further? And I can divide both the numerator and the denominator by 3. And when I do that, I end up with an equivalent and simplified fraction of 1/4. So the final answer to 5/6 minus 7/12 is 1/4. Let's look at problem number 2, where we have 2/3 plus 1/5. So here I need an LCM, a least common multiple, of 3 and 5. So the multiples of 3 are 3, 6, 9, 12, 15. Multiples of 5 are 5, 10, 15, 20. And what I see already is that I have a common multiple in 15, and it is the smallest, the lowest, or we call it the least common multiple. So that means I'm going to convert 2/3 and 1/5 into equivalent fractions with 15 as the denominator. So 2/3 to 15ths, what am I going to do with that 3? Well, what I'm going to do is I'm going to multiply it by 5, which means I will multiply the numerator by 5 as well, which gives me a 10. Now, let's work with the 1/5 and convert that to a fraction with a with a denominator of 15. So let's set that up. And again, we ask the same question. What do I do to get from 5 to 15? And what I do is I multiply by 3. So whatever I do to the denominator, I will do to the numerator. 1 times 3 is 3. So 2/3 and 10/15 are equivalent fractions. 1/5 and 3/15 are equivalent fractions. Now I can add them together, which is what this problem asks us to do. So we have 10 over 15 plus 3 over 15. Our denominator will be 15. Our numerator will be 10 plus 3, which is 13. And this fraction cannot be simplified any further. Therefore, it is our final answer. Now for number 3, we've got quite a bit of work to do. We've got to convert these mixed numbers to improper fractions. So let's be reminded of how we do that. And after we do that, we will subtract. So we're going to multiply the denominator by the whole number and then add the numerator. So for 7 1/3, we will do 7 times 3 plus 1. 7 times 3 is 21, and one more makes 22. So that would give us 22/3. For 1 1/4, we will multiply 4 times 1 and then add 1. 4 times 1 is 4, plus 1 is 5. So that would be 5/4. So now our problem is 22/3 minus 5/4. Well, we have yet another step we need to do. We need to find the least common multiple of 3 and 4. So if we look at the 4 multiples of 4, we have 4, 8, 12, 16. And I notice that 12 is also a multiple of 3. So the least common multiple of 3 and 4 is 12. That means I'm going to convert 22/3 to 12ths. And I'm also going to convert 5/4 to 12ths. So let's change our color so we can see our work clearly. So I know that 3 times 4 is 12. So I will multiply the numerator times 4, and 22 times 4 is 88. I know that 4 times 3 is 12, so I will multiply the numerator of 5 times 3 to get 15. So now I have a problem that says, remember, these are our equivalent fractions. 22/3 is 88/12, 5/4 is 15/12. So now I have a problem that says 88/12 minus 15/12. So I know my denominator will be 12, and 88 minus 15 is 73. Now what I have here is an improper fraction. I want to convert that to a mixed number. So I'm going to divide 73 by 12, and I can use a calculator to help me a little bit. I know that 12 times 6 is 72, so that would give me 1/12 left over. The remainder is our new numerator, and 12 is still our denominator. So we have 6 1/12 as our final answer. So it was a bit of work, but we stuck with it and we did it. So in number 4, 1 3/4 minus 3 9/10. So first we will convert these mixed numbers to improper fractions. We will multiply 4 times 1 and add the 3. So 4 times 1 is 4, plus 3 more is 7. So 3 1/4 as an improper fraction can be represented by 7/4. Now 3 9/10, I'll multiply 10 times 3 is 30, plus 9 is 39. So that would be 39/10. Now I need a least common multiple of 4 and 10 so that I can subtract these fractions. So multiples of 10 are 10, 20, 30. And if I look at that, are any of these also multiples of 4? And indeed, the 20 is a multiple of 4. So the least common multiple of 4 and 10 is 20. So I need to convert 7/4 to 20ths, and I need to convert 39/10 to 20ths. So let's change our color so we can show our work very clearly. So what do I do to get from 4 to 20? What can I multiply by? I can multiply 4 times 5 to get 20, which means I'll multiply the numerator 7 times 5, which will give me 35. I will multiply 10 times 2 to get 20. So that means I will multiply the numerator by 2. And 39 times 2, you could do that in your head. You know that 40 times 2 is 80, and 2 less would be 78. So now my problem will read 35/20 minus 78/20. And that tells me right away I will have a negative number as an answer. So let's rewrite the problem. 35/20 minus 78/20. So when we subtract a smaller number from a larger number, it's like 35 minus 78, which is like adding a negative. So we can think of this as a positive 35 minus 78. So we ignore the signs, subtract the smaller absolute value from the larger. So 78, take away 35 is 43, and give the sign of the larger number. So that would be negative 43/20. Now we have here a numerator that is greater than the denominator. So what we will do is divide 43. Don't forget our answer will be negative. So 2 times 20 is 40 with 3 left over. So negative 43/20 is equivalent to a mixed number of 2 and 3/20. So let's move on to the next page. We have 1/9, plus 4 and 11/12. So first thing we need to do is convert that 4 and 11/12 to a improper fraction. So 4 and 11/12. So that would be 4 times 12 plus 11. 4 times 12 is 48, plus 11 more is 59. So that would be 59/12. So now we have 1/9 plus 59/12. But we need to convert these fractions so that they have a common denominator. So we need to find the least common multiple of 9 and 12. Now, if I think of the 12 times table, I have 12, 24, 36, and I know that 36 is also a multiple of 9. So let's convert 1/9 to 36. And then we'll convert 59/12. We're going to have some big numbers here. You might need a calculator, to 36. So let's change our color here so we can see our work clearly. 9 times 4 is 36. 1 times 4 is 4. So we've got our first fraction there. 12 times 3 is 36. 59 times 3 is 177. So there's our second fraction. So now we have 4 over 36 plus 177 over 36. And when we add those numerators, they add up to 181 over 36. And if we divide 181, let's find a place where we're going to need a little more room than that. If we divide 181 by 36, we will see that I still need to give you a little bit more room. Okay, 6 times 36 is 6 times 6 is 36. Nope, too big. Let's try 5. And this is what division is. It's sometimes guess and check. 5 times 6 is 30, 15, 8. There we go, with 1 left over. So 181 over 36 is equivalent to 5 and 136. And that's our final answer. Okay, let's move on to number 6. We will convert these to improper fractions. 8 times 1 is 9, plus 1 more is 10. 10 over 8 plus 6 times 1 is 6, plus 1 more is 7. 10 eighths plus 7, 7 6, excuse me. I almost wrote eighths. Now we need a least common multiple of 8 and 6. So let's make some room to do our work. So we need a least common multiple of 8 and 6. So let's look at the multiples of 8. 8, 16, 24, 32. Now, are any of these also multiples of 6? Well, 24 is. So we're going to work with 24 as our denominator. So 10 over 8 converted to denominator 24, and 7 over 6 converted to a denominator of 24. So we know that 8 times 3 is 24. Therefore, 10 times 3 is 30. 6 times 4 is 24. So we'll multiply the numerator by 4, which is 28. So I think I have a mistake here. This shouldn't be a 10. This should be a 9. Okay, now let's work on number 6. So we're going to convert 1 and 1/8 to an improper fraction and 1 and 1/6 to an improper fraction. So 8 times 1 plus is 8, plus 1 more is 9. So that would be 9 over 8 plus 6 times 1 is 6, plus 1 more is 7. 7, 6. So we need the least common multiple of 8 and 6. And when we look at the multiples of 8, we have 8, 16, 24, 32. And we see that 24 is also a multiple of 6, so that will be our new denominator. So we need to convert 9 over 8 to 24ths, and we need to convert 7 over 6 to 24ths. So 8 times 3 is 24, 9 times 3 is 27. So that's our first new equivalent fraction. 6 times 4 is 24, 7 times 4 is 28. So that's our second equivalent fraction. So now we can add them together. 27 over 24 plus 28 over 24 equals 55 over 24. And now we'll divide 55 by 24. And 2 times 24 is 48, with 7 left over, so that will equal 2 and 7/24. Let's move on to number 7. Negative 1 5/9 plus negative 2/3. So first we'll convert the first fraction to an improper fraction. 9 times 1 is 9, plus 5 more is 14, so that we will rewrite that as negative 14 over 9 plus negative 2/3. Now we need a least common multiple of 9 and 3. Well, 9 is a multiple of 3, so 9 can be our least common multiple. So our first fraction can stay the same, and our second fraction will be converted to ninths. And we'll multiply both sides, the numerator of the denominator, by 3 to get 9 in the denominator and 6 in the numerator. So negative 14 ninths plus a negative 6 over 9. So negative 14 plus negative 6 is negative 20. And when we divide negative 20 by 9, we see that it goes in there 2 times with 2 left over, which will give us negative 2 and 2/9. Okay, number 8. We have negative 1 3/5 plus a negative 1 1/12. So first we will convert them to improper fractions. 5 times 1 is 5, plus 3 more is 8, so that would be negative 8/5 plus a negative 12 times 1 is 12, plus 1 more is 13/12. Now we need an LCM, a least common multiple, of 5 and 12. Now let's look at the multiples of 12. They are 12, 24, 36, 48, 60. And I know that 60 is also a multiple of 5. So 60 will be my new denominator. So let's make those conversions to equivalent fractions with 60 in the denominator. So 5 times 12 is 60. 8 times 12 is 96. 12 times 5 is 60. 13 times 5 is 65. So our new problem will be, here's our equivalent fractions, 96 over 60, and that's a negative, plus a negative 65 over 60. We add the numerators and keep the denominator for negative 161 over 60. And if I divide 161 by 60, I see that it goes in 2 times with 41 remaining, which means my mixed number answer will be 2, -2, that is, and 41/60 for our final answer. Let's move on to number 9 and 10. So I have -2 minus 3/8 minus a -3/8. Remember, when you subtract a negative, it's the same as adding. So I can think of that -2 as -2 over 1. And remember, subtracting a negative is adding, plus 3/8. And I need to convert the first fraction to eighths. So 2 over 1 to eighths. Well, 1 times 8 is 8. 2 times 8 is 16. So I can convert the first fraction to -16/8, to which I will add 3/8, which will give me an answer of 8 in the denominator. -16 plus 3 is -13/8. Now I can divide 13 by 8, and 8 will go into 13 one time. Remember, this is a negative number we're working with 5 left over. So on number 10, again, we're subtracting a negative, which means we will be adding. So first we make improper fractions. 6 times 2 is 12, plus 1 more is 13. So 13 over 6. Now we need an improper fraction for 1 and 2/9. 9 times 1 is 1, plus 2 more makes 11. So that would be 11/9. Now I need a least common multiple of 6 and 9. And let's look at the 9 multiples. 9, 18, and right there, 6 is a factor of 18. 18 is also a multiple of 6. So that will be my new denominator. So when I convert 13 over 6 to 18ths, I multiply by 3, which means my new numerator will be 39. And when I convert 11/9 to 18ths, I multiply both the numerator and the denominator by 2, which means my numerator will be 22. So my new problem will be 39/18 plus 22/18, which adds up to 61/18. And when I divide 61 by 18, it goes in there 3 times with 7/18 left over, which is our final answer. Now, number 11, I have 1/2 plus -5 and 9/10. So I need to convert the -5 and 9/10 to an improper fraction. 10 times 5 is 50, plus 9 more is 59. So this will be a -59 over 10. Now, the LCM of 2 and 10 is 10, because 10 is a multiple of 2. So I just need to convert 1/2 to tenths, and I multiply 2 times 5, I get 10, so 1 times 5 is 5. So my new equivalent fraction for 1/2 will be 5/10. So 5/10 plus a -59/10. Remember your integers here. So 5 minus 59 is a -54. and let's convert that to a mixed number. First of all, we could also reduce it. 54 and 10 are both divisible by 2, which would give me negative 27 over 5. And that's easy to convert because 27 divided by 5 is 5. Remember, this is negative. Let me make sure I make that clear. So this would be negative 5 with 2/5 left over. Okay, number 12. Let's convert those to mixed numbers. 6 times 4 is 24, plus 3 more is 29. So that would be 29/6. And we're subtracting a negative, which means we are adding 29/6 plus 13/16. We're going to need a fairly large denominator to accomplish this task. So multiples of 16 are 16, 32, 48, and 64. Well, 48 is also a multiple of 6. So we're going to convert our denominators to 48ths. So 29 over 6 to 48ths, and 13 over 16 to 48ths. So 6 times 8 is 48. 29 times 8 is 232. 16 times 4 is 8. 16 times 3, excuse me. 4, that should be a 3. 16 times 3 is 48. 13 times 3 is 39. So I've got my equivalent fractions here. Now I can go ahead and add 232 over 48 plus 39 over 48 equals, and our denominator, of course, is 48. 232 plus 39 is 271. And 271 divided by 48 is 5 with 31 48ths left over. Okay, they're getting a little more challenging, but we can do it. So let's do some word problems. Sarah ran 4 7/8 miles. Then she walked 1 11/12 miles. Find the total distance. So we just need to add those together. First, she ran 4 7/8 miles. Then she walked 1 11/12 miles. So we'll convert those to improper fractions. 8 times 4 is 24. 32 plus 7 is 39. So 39/8 plus 12 times 1 is 12 plus 11 is 23/12. And our least common denominator, multiple of 8 and 12 is 24. So we'll convert 39/8 to 24ths, and we will convert 23/12 to 24ths. And when we do that, we have 8 times 3 is 24, 39 times 3 is 117, 12 times 2 is 24, 23 times 2 is 46. So these are our new equivalent fractions. And we'll simply add 117 over 24 to 46 over 24 to get 163 over 24. And when we divide 24 by 163, we have 6 and 19/24. And the question is the total distance in miles. So 6 and 19/24 miles. So now a pitcher contains 18 and 5/9 ounces of apple juice. If 7 and 2/3 ounces is poured out, how many ounces are left? So this is a subtraction problem. 18 and 5/9 minus 7 and 2/3. And let's convert to improper fractions. 18 times 9 plus 5 is 167 over 9. Minus 7 times 3 is 21, plus 2 is 23/3. Now, our least common multiple will be the ninths because it is a multiple of 3. So our first fraction will stay at 167/9, but 23/3 converted to ninths, 3 times 3 is 9, 23 times 3 is 69. So 167/9 minus 69/9 equals 98 over 9, which we will convert. 98 divided by 9 is 10 with 8/9 left over, and we are answering this in ounces. So 10 and 8/9 ounces were left in the pitcher. And our last two problems for today. Sorry, we have 4 more. Owen and Scott each ordered a pizza for lunch. Owen ate 9/16 of his pizza. Scott ate 3/4. How much more pizza did Scott eat than Owen? So we're going to subtract Owen from Scott. Scott ate more. He ate 3/4. Owen ate 9/16. This is a subtraction problem. So our least common multiple will be 16. So 3/4, we will convert that to 16ths by multiplying the numerator and denominator by 4. So that would be 12/16 minus 9/16, which equals 3/16. And we're talking about pizza. So Scott ate 3/16 more pizza. And that's our final answer. Number 16, if 4/15 of the candies in a bag of Skittles are red and 3/10 are yellow, what fraction of the bag are red or yellow? This is an addition problem. What fraction of the bag are red or yellow? So we're going to add 4/15 and 3/10. So we need a least common multiple of 15 and 10. So the multiples of 15 are 15, 30, and right away we see that's a multiple of 10. So 4/15 to 30ths and 3/10 to 30ths. So 15 times 2 is 30, 4 times 2 is 8, 10 times 3 is 30, 3 times 3 is 9. So now we have our equivalent fractions of 8/30ths plus 9/30ths. And when we add those up, we have 17/30ths of the bag are red or yellow. And we cannot simplify that any further. So now we're at the last two problems. Last night, Olivia spent 1 2/5 hours on her math homework. Oh, good for her. Then 45 minutes on her science homework. What was the total time? So we know we're adding 1 2/5 plus 45 minutes. This is a trick question. 45 minutes equals 3/4 of an hour. So it's 1 2/5 plus 3/4. Let's convert 1 2/5 to an improper fraction. 5 times 1 is 5, plus 2 more is 7/5 plus 3/4. And the common multiple of 5 and 4 is 20. So 7/5 equals 5 times 4 is 20. 7 times 4 is 28. 28/20. 3/4 equals 4 times 5 is 20. 3 times 5 is 15. So 28/20 plus 15/20 equals, oops, should have written 20 there, 43/20. And 43 divided by 20 is 2, with 3/20 left over. So it was 2 3/20 hours Olivia spent on her homework. Good girl for working that hard. Finally, Kara is 5 feet 6 inches tall, and her husband Jack is 6 feet 2 inches tall. Find the difference in their heights. So 5 feet 6 inches tall. I would never do this as fractions. I think the easier way to do it would be to convert them to inches and do them as inches. But let's try this fraction work. So Jack is 6 feet 2 inches tall. He's taller. So it's going to be Jack minus Kara, who is 5 feet 6 inches tall. So 6 feet and 2 inches. 2 inches is 2 of 12, which we can reduce to 1/6. So Jack is 6 1/6 inches tall. Kara is 5 6 out of 12 inches, which equals 1/2. But let's convert that to 6. So 2 times 3 is 6. 1 times 3 is 3. So we're going to make Kara 5 3/6. So that way we can easily make equivalent fractions. So with common multiple denominators. So 6 times 6 is 36, and 1 is 37. We'll make improper fractions now. Kara, 5 times 6 is 30, plus 3 is 33/6. Now we can easily subtract. 37 minus 33 is 4/6. If we divide both the numerator and the denominator by 2, we see that equals 2/3. And that's 2/3 of a foot, which is also 8 inches because there are 12 inches to a foot. That's how much taller Jack is than Kara. So good job today. Remember to organize your papers in the binder from oldest to newest. Okay, so your newest page goes last behind everything else you've already done, and return your binder to the box. I hope you've actively participated in our meditation. I hope you completed our work page and you understand least common multiple. And I hope that your binder is updated, because those are the ways to an A. And I'm super proud of how hard you've been working in math. Keep up the good work, because the more you practice, the better you'll be.